Okay, today for 2.6a, we are talking about functions that have a horizontal and a vertical asymptote. So let me give you an example here. 1 over x minus 3. Okay, so to find your horizontal asymptote. An asymptote is just a fancy word of saying this is a line that your function cannot cross, can't touch it. So a horizontal asymptote looks like this. It's a straight line. So it's going to be a y equals something, right? Y equals something. And to find that asymptote, what we have to do is we look at all of our x's. We look at all of the largest x's in the numerator, and we compare that to the largest x's in the denominator. Well, there are no x's in our numerator here, so here we can say, oh, there's no here where the bottom one has a 1x, so I'll just put that 1. There is no similar x on the top, so our horizontal asymptote is actually 0, or y equals 0 would be our horizontal asymptote here. So if I then were to draw this, I'm gonna draw the asymptote. I'll draw that blue, or just a dotted line. You don't really draw the asymptote for a way. It's normally just a dotted line, and sometimes since it's on the axis, you don't even see it in itself. But then let's look at our vertical asymptotes. Well, our vertical asymptotes are whenever the function, the denominator, equals to 0. So if we have x minus 3, we set that equal to 0, and x equals 3. So that is our vertical asymptote. So at 3 here, I'm just going to say that's 3. There's going to be a dotted line. Next, to round off our function, we need to know how to graph it, right? So now we have like kind of a checkered pattern, and if it's positive, we kind of want to have like a positive slope in a way for our checkered pattern, if that makes at all sense at all. So what we do is, it can never be 0. It's gonna get close. It can never be 0. It can never be this other thing. It's gonna get close, but it will never touch, and it will go the other way too. It will get close, but it will never quite touch. And the red line is how we would graph it. Let's say we want to then find out what this point is. What is that? The y-intercept is what we'll call that. Well, to find the y-intercept, all we have to do is just get the coefficients, or the constants of the numerator and the denominator. So our y-intercept here actually equals 1 over negative 3, or negative 1/3. So that is actually negative 1/3 up there. And since we cannot touch 0 at all, our x-intercept, if they asked us, oh, what is our x-intercept? Well, we can never touch 0, so it does not exist in this case. Let's do another quick example without having to graph. What if we had a x plus 2 and a 2 minus x? Okay, if we first want to know our horizontal asymptote, well, we have an x on top and we have an x on the bottom. Their coefficients are 1 and over -1, so it's actually -1 would be our horizontal asymptote. Our vertical asymptote, of course, we take the denominator and we set that equal to 0. So here we have 2 minus x, set that equal to 0. X then equals 2. Our y-intercept is our constant, which constants, which would be here our y-intercepts is 2 over 2, which makes it 1. And then our x-intercept here, notice that there's an x on top and then an x on the bottom. So here the x-intercept is actually what makes the numerator go to 0. So all we have to do is set that equal to 0. Here for the x-intercept, we do x plus 2 equals 0. X equals -2. This is our x-intercept here. And that is how we would find all these algebraically. And let's do one last example. Here, let's say we had 3x over x squared minus 7x minus 8. I already know that the x over the x squared, that my y or my horizontal asymptote is going to be at 0. To find my vertical asymptotes, I just need to factor. So if I factor this is x 8 times 1, right? 8, 1, -8, +1. So x equals 8 and x equals -1 will be my asymptotes here. So here if I draw a blue line, a dot 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 at y equals 0, and then an up and down at 8 and -1. So here is 1, 1, 2, 3, 4, 5, 6, 7. Oh, this is the other side here. This would be 8 per se. My coefficients are positive in front of my x squared. So this is going to be a positive. So a positive, I'm going to go start here down below. And then here in the middle, it's not like it doesn't cross. It actually crosses. And then it's going to go down. And then it's going to look like that. Had my coefficient been actually negative, I'll draw a green line to show where our negative coefficient, it would be the opposite way here. We'd go on top and then it would look like this per se and look like this. But luckily for us, well, luckily not lucky, it is positive, so we're just gonna leave it like this here. Try to fix this a little bit here, and so let's find the other last values of our x-intercepts and y-intercepts here. Remember the y-intercepts is our constants. On top, our constant doesn't exist, so actually the constant on top would be a 0, and the constant on bottom is -8. that gives us a 0 for our y-intercept. And then, so then actually, if I fix this red line a little, because to mirror what it's supposed to be, it should cross at 0 here. So I'm gonna guess my x-intercept is 0, but it will also, we can confirm that because what we do is we take our numerator for our x-intercept, set that equal to 0. 3x equals 0, well, x has to equal 0 for our x-intercept.